distance and displacement, we are going to learn about speed. I gave you the example of speed when we were discussing scalar quantities, scalar and vector quantities. So the speed is a scalar quantity, and you know what is a scalar quantity. The scalar quantity, it should have only magnitude and only, that's it, no direction. So if I write over here 10 meter per second, here we have the magnitude and the unit also. So that is the thing that we need to define, that we need to tell about speed. No direction is required here. Suppose that I am asked to define speed. What do I state? What is speed? It is the rate of change of distance. Now let me tell you something. Whenever you see this term rate is being used anywhere. The rate means per unit time. Whenever you see this term in physics that rate is being used, rate means that is the per unit time, the change of distance per unit time. So we can also define speed as it is the change, or we can also state here that it is the distance covered by the body per unit time. It is the distance covered by the body per unit time. Now, the term unit means one. It means that we are talking about the distance covered by the body in 1 second. You know about the SI system. The SI unit for time, it is second. So, what is the statement here? It is the distance covered by the body per unit time, or you can also write here, it is the distance covered by the body in 1 second. So this is about speed. What is the SI unit of speed? As you can see here, what is it? What is speed? I'll write the expression for speed. In general, speed is denoted by V. So as per your definition, what is speed? What is V? It is the distance covered. In general, the distance covered, the distance is denoted by S, or somewhere you can also find the letter D, so small d or capital D, but generally we use the term S, letter S, to denote distance. So what is speed? It is the distance covered by the body per unit time. So it is the expression for speed. As you can see here, the SI unit for distance will be meter and SI unit for time will be second. So what must be the SI unit for speed? That is meter per second. Now, there are some basic terms that are related to speed. We'll discuss about it. Suppose you are being told that a body moves with uniform speed. Let me tell you, whenever you see this term uniform means constant. That remains the same, that remains constant. So uniform speed means the speed would remain, I'll write here, uniform means constant or the same. So whenever you see this term uniform means constant, it would remain the same. So the uniform speed means the speed would remain the same, the speed would remain constant. I'll give you an example for it. Suppose you ride a bicycle at a speed of 20 meter per second. After 5 minutes also, you are riding the bicycle with the same speed, with 20 meter per second. Then I say that you are moving with uniform speed. The body is moving with uniform speed. I'll write the definition over here. If the body covers equal distance in equal interval of time, then the body is said to be moving with uniform speed. So let us understand it clearly with the help of an example. Suppose I am here at the position A and I start to move in this direction. Then After some interval of time, I reach the point B, the position B. To do this, I take a time of 1 second. The time interval is of 1 second. And suppose that the distance between, the length between the points A and B, position A and B is 2 meter. Suppose that. Now, after this, I again travel a distance, I again cover a distance of 2 meter and I reach the point C. During this, the time interval is also 1 second. And after this, I reach the position D after covering a distance of 2 meter, and here also the time taken by me is 1 second. What do we conclude here? From coming from A to B or B to C or C to D, what is the distance covered by me? It is 2 meter, 2 meter, 2 meter. And what is the time taken by me? 1 second, 1 second, 1 second. So what do we conclude? When I come from A to B, I cover a distance of 2 meter in 1 second. When I come from B to C, I again cover a distance of 2 meter in 1 second. And in C to D, from C to D, I again cover a distance of 2 meter in 1 second. So what do we conclude? The speed, my speed when I go from A to B was 2 meter in 1 second. We can write it as 2 meter per second. When I was moving from B to C, again the speed was 2 meter per second. That is 2 meter in 1 second. And from C to D, again my speed was 2 meter in 1 second. That is 2 meter per second. So what do we conclude here? I cover equal distances. The body covers equal distances in equal interval of time. The time interval here is also equal, 1 second, 1 second, 1 second, and the distance traveled by me, covered by me in this equal time interval is also equal. So I say that the body is moving with, I am moving with uniform speed. I think that it must be very clear to you. After this topic, that is about speed, we'll get to know about velocity, and that part also we will compare the same thing. I'll let you know that what is uniform velocity in the next topic. So the next part, if I tell that the body is moving with non-uniform speed, as the term sounds, non-uniform, it means that this time the speed wouldn't be constant, the speed wouldn't be the same. So I'll define non-uniform speed here. I'll rub this part. What is non-uniform speed? You can define it of your own. Uniform speed, you got to know about it. It means the body covers equal distance in equal interval of time. Now, what about this term, non-uniform speed? If the body covers unequal distance in equal interval of time. Very simple it is. Again, we will take an example, simple example to illustrate it. Suppose I was at this position A and I start to move in this direction and I come to a position B. Suppose that the distance covered by me is of 2 meter and the time taken by me is of 1 second. Next, I move from B to C, and while I move from B to C, I cover a distance of 3 meter and the time taken by me was of 1 second. Then again, I come from point C to point D, and this time I covered a distance of 5 meter when I move from C to D, and then again the time taken by me was of 1 second. What do we observe here? The distance covered by me is different, but the time taken by me in these in the process when I am moving from A to B, B to C and C to D, the time interval is always the same, 1 second, 1 second, 1 second. But what is different here? The speed. The speed is different. What about the part AB? When I move from A to B, what is my speed? 2 meter in 1 second. That is, my speed is 2 meter per second. When I move from B to C, I cover a distance of 3 meter in 1 second. It means that here my speed is 3 meter per second. And then when I come from C to D, I cover a distance of 5 meter in 1 second. What is my speed here? 5 meter in 1 second, that is 5 meter per second. What do we conclude here? The distance covered by the body, by me, is unequal for equal interval of time. The time interval here is equal, 1 second, 1 second, 1 second, but the distance covered by me is different. So I say that the body, I am moving with non-uniform speed. I think this is also very clear to you. After it, if the body is moving with non-uniform speed, you might be asked about the instantaneous speed. As the term sounds, instantaneous speed. The term instantaneous, it comes from the term instant, and you know very well about what is instant. Whenever we hear the term instant means it is very small interval of time. It means that milliseconds, fraction of seconds. So we will define instantaneous speed. I'll give you an example for it. Suppose you are riding a bike or a scooty. You look for the speed. Where? On the speedometer. The speedometer, it tells us about our speed at that very moment. Suppose the friend behind you, he asks you that what is our speed? Now only, at this very moment only, what is our speed? You look to the speedometer and tell him that we are moving with a speed of 40 km per hour or 60 km per hour. So that thing, that speedometer, it tells us about our present speed, our speed at that very particular moment. So what is instantaneous speed? It is defined as the ratio of distance covered by body in a short time interval. Keep it in mind that time interval should be very smaller, very short time interval it should be. It means that it should be a fraction of seconds, milliseconds. In a short time interval to the time interval. I emphasize here, if you are asked to define instantaneous speed, you will define it like this only. We have more examples for it. We'll take it later. We'll discuss about it later. What is it? What is instantaneous speed? It is defined as what? As the ratio of distance covered by the body in a short time interval to the time interval. So it is instantaneous speed, and it would vary time to time. Suppose you are riding the bike or scooter or scooty. So now only if you are asked that what is your speed, you state that 40 km per hour. Suppose that after you move 1 or 2 kilometers, there is traffic jam, and obviously you will take the brakes, you will apply the brakes, and your speed will be decreased. So in that condition, at that particular instant of time, your speed has decreased. Your speed, suppose that your speed is 30 km per hour or 20 km per hour. So the instantaneous speed, it would be different for different instant of time. I think it must be clear to you, instantaneous speed. And what about the formula, the expression for it? If you are given a numerical and you are being asked to find the instantaneous speed, very simple, instantaneous speed. The expression for it, here you have the expression for it. What is it? It is the ratio of distance covered by the body. Distance covered in short time interval. In short time interval to what? To the time interval. So this was about instantaneous speed. It means that the speed of the body at this particular instant, at any particular instant. So in that condition, when we are talking about a particular instant of time, it means that the time interval has to be very small, has to be taken very small. Now we move to the next term, that is about average speed. As the term sounds, average. You might have learned about the average, the arithmetic mean in mathematics. What do we do there? We sum up all the numbers and divide it by the number of terms. So basically, what is average? It is overall. What is average speed? I'll define it over here. If we are being asked to define average speed, it's very simple. What is average speed? Sometimes you might see that the average speed, it is denoted by this symbol, that is VAVG, that is average. So we will define it. What is it? Again, it will be defined as the ratio of what? As the ratio of total distance traveled by the body to the total time taken. So this is the average speed. I haven't defined it here. I think that you can define it of your own. What is it? It is defined as the ratio of what? The ratio of total distance traveled by the body to the total time taken. I'll give you a simple example for it. Suppose I start from this point A. I move to a point B. And the distance between these 2 points, suppose that it is 5 meters. Again, I start from this point to move and I reach a point C, a position C, and the distance between these 2 points, the length between these 2 points is 7 meters, suppose that. When I move from A to B, I take time of 2 seconds. And when I move from B to C, I take a time of 3 seconds. So what do we conclude here? The total distance traveled by me is from A to B 5 and from B to C 7. So what is the total distance traveled by me? 5 plus 7, 12. So if I have to find the average speed, 5 plus 7, that is the total distance traveled by the total time taken. What is the total time taken? 2 seconds plus 3 seconds. It is the total time taken. So what is it? 2.4 meter per second. It is my average speed. So I think that it must be very clear to you. I'll give you a simple example, one more example to understand it. Suppose in the numerical you are given that you have to find, I'll give you a question. Suppose I start from this point and going towards this point, that is B, or any vehicle. Suppose we are talking about a train. A train starts from a station A and moves towards the station B. And suppose the uniform speed, we are talking about the uniform speed. I already told you about the uniform speed, you know about it. Uniform speed, suppose the train is moving with a uniform speed of 30 km per hour. And the time taken by train to reach from A to B, it is also given to us, that is suppose 3 hours. Understand the question, it's very simple. The train starts from point A and moves towards the station B, and the train is moving with uniform speed, means the train will cover 30 km distance in each hour. Per hour, in each hour the train will cover a distance of 30 km, and the time taken by the train to reach to the station B from the station A, it is given to us, that is 3 hours. Let us make it more simpler, but you need not to do this in your examinations. I am doing it just for you so that you can get it easily. The time provided here is 3 hours. Suppose 1 hour, 1 hour and 1 hour, 3 hours. V, that is the speed, 30 km per hour. You know about uniform speed. In uniform speed, the body covers equal distance for equal interval of time. It means that the body will cover in the first 1 hour, the body will cover 30 kilometer distance. In the next 1 hour, the train will again cover a distance of 30 kilometer. And in the further next 1 hour, the train will again cover a distance of 30 kilometer. We are told that the train is moving with uniform speed. It means that for equal interval of time, the train will cover equal distances. As we can see here, the train, it covers 30 kilometer in the first hour, 30 kilometer in the next hour, and again 30 kilometer in the next 1 hour. So what do we conclude here? The total distance covered by him is 30 plus 30 plus 30, that is 90 kilometer. But now I tell you how to do it mathematically. You need not to do this. This was just for you to get it simply. The time is given to us and the speed is also given to us. So whenever you are told that the body is moving with uniform speed, it means that the body will cover equal distances for equal interval of time. So in that case, we have 3 hours. In the first hour also, the train covers distance of 30 kilometer. In the next 1 hour, it will cover 30 kilometer, and in the last 1 hour also, it will cover a distance of 30 kilometer. So in this case, as you know, we defined speed, that is V. It is equals to distance covered by the body per unit time. So if we are asked to find the distance only, what do? It will be V into T, that is speed into time. Here we have the speed 30 km per hour and we have the time also, that is 3 hours. So what do we get? The distance between the two stations, the station A and B, is 90 km. I think that with the help of this example, it must be very clear to you that when do we use this expression, distance is equals to speed into time, it will be used only when the body is moving with uniform speed. If it is not the case, I'll tell you about it, that the body, if it is not moving with uniform speed, what do we do to find the distance or to find the displacement? So it was all about speed. Now we'll get to know about velocity. Now in this part, we'll talk about velocity. Now as you know about speed, that was the scalar quantity. Now it will be easier for us to know about velocity, and obviously velocity, it is a vector quantity. As I told you earlier, that whenever we are about to represent any vector quantity, then what do? Suppose that to represent velocity, the symbol, it is same as the symbol of the representation of speed. For representing speed also we use the same symbol V, but the difference here is that it was a scalar quantity and the velocity is a vector quantity. So in order to represent velocity, we will have this letter V and we will put an arrow above it. So this is the representation of velocity, that is a vector quantity. Now we'll define it. What is velocity? What is it? As you defined speed, what was it? It was the distance covered by the body per unit time. So the only difference here, it must be the direction. As you know, in the scalar quantity there was magnitude and unit, but in the vector quantity we will have the magnitude, the unit, as well as the direction also. So we define velocity here. It is the distance covered by the body in a particular direction. Per unit time, or we can write in 1 second. I think you are getting it, this part, per unit time, or you can use here this term that is in 1 second. So what is velocity? It is the distance covered by the body in a particular direction. Now you get the difference between speed and velocity. In speed, what we wrote there, in speed, it is the distance covered by the body per unit time. That's it. About speed, it was enough. That much information was enough to define speed, the scalar quantity. The distance covered by the body per unit time, or in 1 second. That was about speed. But The difference here in velocity is only this part, that is about direction. In a particular direction means in a given direction. Suppose I am told to move in this direction only, then this direction, this line is my direction of motion. So I am moving along this direction, along this particular direction, that is given to me. So what is velocity? It is the distance covered by the body in a particular direction per unit time. So this is velocity. The velocity will have the same unit, that is meter per second. The SI unit for it is also meter per second. Now suppose I am told that a body is moving with 10 meter per second. Is this much information enough to define the velocity of the body? No, obviously not. Because here we see that we have the magnitude, we have the unit, but we do not have the knowledge of direction. Where, along which direction is the body moving? So that much information is not enough to define velocity. If I write here 10 meter per second, the body is moving with a speed of 10 meter per second due east. The body is moving with a speed of 10 meter per second due east. So this is the magnitude and unit, and this is the direction. So this will define velocity of any body completely. Whenever we use this term speed, it means that we are talking about the magnitude of velocity. What is speed? Speed is the magnitude of, I'll write it over here. What is speed? It is the magnitude of velocity. And along with the speed of the body, if the direction also is also given, then it will be the velocity. If I write only this part, speed of 10 meter per second, there is no direction, then obviously it is the speed of the body. But if I include this part also, due east, that is the direction, then this will be the velocity of the body. Now as you know the velocity of the body, now we can move to the next part, that is about uniform velocity. As in the last part we were talking about the uniform speed, in this part we will be talking about the uniform velocity. So what is uniform velocity? Firstly, recall about uniform speed. I told you about it earlier. What is uniform speed? If the body covers equal distance in equal interval of time, then the body is said to be moving with uniform speed. But here we have to define uniform velocity. It means that along with the magnitude and unit, there must be direction also. So we'll define it. If the body covers equal distance in a particular direction in equal interval of time, then the body will said to be moving with uniform velocity. Now compare these two parts, uniform speed and uniform velocity. In uniform speed, what did we do to define uniform speed? If the body covers equal distance in equal interval of time, that's it. That was about uniform speed. But the only difference about uniform speed and uniform velocity, what is that part? This, the direction. So what do we define? How do we define uniform velocity? If the body covers equal distance in equal interval of time, but we have to mention about the direction also. If the body covers equal distance in a particular direction, in a given direction, in equal interval of time, then the body will be said to move with uniform velocity. I think it must be very clear to you. The only difference between uniform speed and uniform velocity, what is it? It is about mentioning the direction. So it was uniform velocity. Now, if you are asked to define non-uniform velocity, firstly we will have a simple example. Suppose there is a body A and a body B. When do we say that both the bodies are having the same velocity? Firstly, we will know about the speed. When do we say that both the bodies have the same speed? For the speed to be same, we need only the magnitude and unit. If the magnitude of speed of both the bodies is same, 20 meter per second, 20 meter per second, then we say that both the bodies are moving with the same speed. But if we are asked that is the velocity of both the bodies same, is the velocity of body A and body B same, then only this much information is not enough. We need to know about the direction also. And as we can see here, suppose this direction is east. This is also east. As we can see here, both the bodies are moving towards the east, towards the same direction. And the magnitude is also same. The magnitude of speed is also same and the direction is also same. Then for velocity, what do we need? The two things. The magnitude as well as direction. If the magnitude and direction both are same for both the bodies, then the bodies are said to be moving with same velocity. Now we come back to our topic, that is about non-uniform velocity. So if we talk about non-uniform means the velocity would not be the same, would not be constant. So if we need to change the velocity of a body, we have two options. We can do two things. Suppose the body, it moves in this direction. If we have to change the velocity of the body, we can change two things. Either we change the magnitude of speed, magnitude of velocity. Suppose the body was initially moving with 10 meter per second. The magnitude of velocity is 10 meter per second. And when it reaches this point B, after it continues to move further, suppose from B to C it covers again some distance, but this time it covers the distance with a speed of 5 meters per second. What do we conclude here? The speed was here, the magnitude of velocity, that is speed, was here 10 meters per second and here it is 5 meters per second. So the magnitude has already changed. So we say that the body is moving with non-uniform velocity. Now, the next case, if we say that the magnitude is same but the direction has changed, the direction is different now, then also the body is moving with non-uniform velocity. I'll give you the example. Suppose the body was moving with 10 meter per second. The speed was 10 meter per second. The magnitude of velocity, that was 10 meter per second. And then after, it changed the direction and come to some point B. Now, suppose that in this process also, during this process also, when it comes from, suppose this is point C, it comes from point C to point B. The magnitude of velocity is also 10 meter per second. Here also it is 10 meter per second. But what about the direction? Initially the direction was from A to C in this direction. And then after, the direction has changed. Now the direction is not in this direction. Now the direction is in this line, along this line. So what do we conclude here? If we say that the body is moving with non-uniform velocity, then there might be two cases possible. Either the magnitude of velocity has changed, or the magnitude, if the magnitude is same but the direction has changed. So two cases are there for which the body can be said to move with non-uniform velocity. Now we will define it. If the body covers unequal distance in a particular direction. If the body covers unequal distance in a particular direction in equal interval of time. As you have defined the non-uniform speed earlier, it's very simple for you to define the non-uniform velocity. What is it? If the body covers unequal distance, recall the last part about the non-uniform speed. At that, in that case, what did we do? If the body covers unequal distance in equal interval of time, then the body is moving with non-uniform speed. But here we have to define velocity. So there must be direction mentioned here. So what is it? If the body covers unequal distance in a particular direction in equal interval of time, then the body is said to move with non-uniform velocity. So what do we conclude here? Look for the example. If the body covers unequal distance in a particular direction, as I told you in this example, the body, it covers the distance along this direction. The direction while it was moving from A to B or from B to C, the direction hasn't changed. The direction is particular. The body is moving in a particular direction. But what has changed here? The magnitude of velocity has changed here. So we can see if the body covers unequal distance in equal interval of time, but the direction was same, then the body is said to be moving with non-uniform velocity. And what about the second case? How can we define it? Or I think you can define it of your own. What should be the definition? The next definition for non-uniform velocity: if the body covers equal distances, if the body covers equal distances for equal interval of time, but the direction has changed here. I'll write it over here. Or how can we define it? I'll write it over here. Or I'll write it over here. Or if the body covers equal distances in equal interval of time, but not in a particular direction. It's very simple part. You just have to compare the two cases. That here the magnitude of speed, the magnitude of velocity was different, and here the magnitude of velocity is same, 10 meter per second, 10 meter per second. This is the example here, but the direction has changed. Initially the direction was in this direction, and now the direction is this. So what is non-uniform velocity? If the body covers equal distances in equal interval of time, as you can see here, but not in a particular direction. The direction is not particular. The direction has changed. The direction has changed from this to this. So we can define non-uniform velocity in the two ways. Either the magnitude of velocity has changed or the direction has changed. So this was about non-uniform velocity. Now we move to the next part, that is about the instantaneous velocity. As I told you about the instantaneous speed, now you can define the instantaneous velocity of your own. The only difference between these two terms will be what? About the direction. Instantaneous speed and instantaneous velocity. So now we come to instantaneous velocity. Again, the same part. How do we define it? It is defined as the ratio of, as in the earlier case, it was the ratio of what? It was the ratio of distance traveled by the body in a very short time interval to the time interval. So here we have the same part, but the difference here is about the direction. We have to mention the direction also, because we are talking about instantaneous velocity and not instantaneous speed. So it is defined as the ratio of what? The direction. It is defined as the ratio of distance, of the distance covered by the body in a short time interval. Along a particular direction. To what? To the time interval. As you can see here, the only difference between the instantaneous speed and the instantaneous velocity. What is it? It is defined as the ratio of the distance covered by the body in a very short time interval, and the direction is also mentioned here, along a particular direction or in a particular direction, to what? To the time interval. So it must be very clear to you that what is the difference between instantaneous speed and instantaneous velocity. In general, whenever we are asked about speed or velocity, if we are asked about instantaneous speed or instantaneous velocity, there is no difference between them. I'll tell you why. Suppose if we are moving on this circular path, at this instant of time, when I am here, if I am asked that what is my instantaneous speed or what is my instantaneous velocity, then in this case, what do we do? Suppose I am here. As I told you, the time interval is very short, and in that short time interval, the distance covered by the body, it would be minimum. It would be negligible. So here, if I am asked about the velocity, my instantaneous velocity, then the direction is this. And when I am asked about the instantaneous speed, though the direction is not required here, but the direction won't change, either in the case of instantaneous speed or in the case of instantaneous velocity. Now we will get to know about the average velocity. As I told you about average speed, again the same part, the only difference between average speed and average velocity, it would be about the direction. So how do we define average velocity? It is defined as the ratio of total displacement to the total time taken during the motion. Obviously, when the body is moving. So what is average velocity? It is defined as the ratio of what? Ratio of total displacement to the total time taken. So I'll write the expression here. Velocity, as I told you, the velocity will be represented by this symbol, that is V, the letter V, and above it we will put an arrow. V average, that is the average velocity. What is it? Total displacement, that can be represented as this symbol S, and above the S we will put an arrow, to the total time taken, that is denoted by small t. So it was about average velocity. I'll give you a simple example for it. Suppose in the numerical you are given that a body starts from position A and go towards B, and during this process, when it moves, the body moves from point A to point B, the body covers a distance of 5 meters. And then after, he again starts to move from the point B to towards the point A. And after that, finally, he again comes to the point A. What do we conclude here? The initial position was also B, and at the end of this process, when the motion of the body ends, when the body stops, it is again at the same position, at the position A. So the position A, it is the initial position and it is only the final position. So in this case, what is the distance? Total distance, what is it? What is the total distance? I am giving you this example so that the concept of your average speed and average velocity is clear. And you might be asked about, in the numerical part, you might be asked about finding the average speed or average velocity. So look here. Distance, the total distance here will be from A to B 5 meter and again from B to A 5 meter. That is, total distance traveled is 10 meter. Suppose that the total time taken when he was going from this to this point A to B and from B to A. While he was going from A to B, suppose it was T1, it is given to us, that is 2 seconds. And when he comes from B to A, he returns back from B to A, he takes time of 3 seconds. So what is the total time taken here? T1 plus T2 while going 2 seconds and while returning 3 seconds. So the total time here is 5 seconds. So if I am asked to find the average speed, so what was the average speed? It was the ratio of total distance covered to the total time taken. So it's very simple. It is 10 by 5, that is 2 meter per second. But if I am asked to find the average velocity, what will be the average velocity? As I told you, the average velocity, what is it? Total displacement by total time taken. So in this part, if you are asked to find the average velocity, what do? Total displacement by total time taken. Now look here, what is the total displacement here? He started from A and he went to the point B. Again from B to A, he returned from the point B to A. It means that the initial and the final position are the same. It means the displacement of the body is, total displacement is 0. We have done it earlier also in the example. What is the total time taken? 2 seconds plus 3 seconds, that is 5 seconds. But it doesn't matter because the total displacement here is 0 meter. So what is the average velocity here? It is 0. So it was about the velocity part. Now we will discuss about acceleration.